Balloon payment. If an annuity consists of some level payments and a final payment that is larger than the regular level payments, then the final payment is called a balloon payment. And if the final payment is smaller than the other regular payments, and the other regular payments are level payments, then the final small payment is called a drop payment. So let's understand them by examples. A loan of 800 is to be repaid with some level annual payments of 100 and a final payment that is larger than the regular payment. Each payment occurs at the end of the year. Find the final larger payment. Interest rate is 6%. So it's an annuity immediate since payments are being made at the end of the year. So present value equals x times 1 minus 1 plus I to the negative L over I, the basic formula for present value of annuity immediate. And the present value is the loan value, which is 800. And the level payments are 100. So first, what we're doing is we're trying to find n as if all the payments were level payments, and we are for now ignoring the last payment being different. So when we substitute, we end up getting n is equal to 11.22. Now, remember, n is the number of payments, which has to be an integer. So 11.22 payments make no sense. So what our calculations are really telling us is that once you've made 11 regular payments, you only need 0.22 of a regular payment in the next period in order to pay off the loan. And since we want the final payment to be larger, so what we'll do is we'll make 10 regular payments, and then in the 11th payment, we'll have a larger amount because as the calculations are showing, 11 payments are not paying it off completely. There is still a part left. So in the 11th payment, instead of the 11th payment being a regular payment, we will also include the part that is left. So that means we'll make 10 regular payments and a larger 11th payment. So let the larger 11th payment be y. And now the equation that we set up is again the present value of loan equals present value of all the payments. And now we break up the payments into present value of 10 regular payments plus present value of the 11th payment. So 800 was the present value of the loan, and now we use the annuity formula for 10 payments. And the 11th payment is sitting at time 11 because it's annuity immediate, and an annuity immediate, the payments happen exactly at the time. So for example, first payment happens at time 1, second payment happens at time 2, and so on. The 11th payment will happen at time 11. So once you subtract all this expression from the 800 and then multiply both sides by 1.06 power 11, you get y equals 121. And that's the that's a larger balloon payment. See, it needs to be larger than all the others, and all the others were 100, and this larger one is 121. And now let's see an example to understand the drop payment. So I've basically recreated the same scenario. This time, instead of a loan of 800, I have a fund of 800, and instead of repaying the loan, you're using that fund to get an annual income of 100 at the end of each year. So that part is still the same as far as the annuity is concerned. And a time will come when the fund will not have 100 left at the end of a certain year, and then you just want to get whatever is left at that time. And that means in this case, the final payment will be a small payment. So they're saying there comes, but when a time comes that the fund cannot pay 100 at the end of a certain year, then the final payment equals whatever is left in the fund. That will obviously be less than the 100. Find the final payment. And it's again starts the same way. We first try to find n as if all the payments were 100, and again comes out to be 11.22. So what that means is that we can have 11 complete payments of 100, but we can't have more than 11, because after that only 0.22 of a payment is going to pay 100, which basically is saying that we do not have 100 left by the time of the next payment period. So we will get the 11 regular 100 payments that we can get. And then the last payment, which will be the 12th payment in this case, will be smaller. And let the smaller payment be y. So we set up again the same equation, present value of loan equals present value, well, not loan in this case, present value of fund equals present value of the 11 regular payments this time plus present value of the 12th payment. So we have the annuity formula for 11 payments and the 12th payment is sitting at time 12. So you bring it back through a factor of 1.06 to the negative 12. And in this case, we end up getting y equals 23. So as we expect, this is a smaller payment than the regular ones of 100. So this is the drop payment in this case. And now we are ready to do a few more SOA problems relating to balloon and drop payments. And that next few videos will be over some of the SOA problems.